Question 5 reads as follows. A firm makes and sells a computer for $500. Variable cost to produce a computer for the range of production of the firm is $300 per unit. Fixed costs per year to make the computer are $1 million. How many computers must be made and sold, given this information, before the firm makes a profit? So the first thing we want to do here is sort of mark everything we have. Our junior tutors started nicely. So I'm going to denote profits with the pi symbol, which is pretty standard in economics. And as we know, profits are composed of the total revenue, the total revenue minus total cost. In that, total revenue is going to equal the price of the good, P, times the quantity of goods produced, Q. Total cost is going to be made up of our fixed cost plus our variable costs. So fixed costs are essentially what you're going to have to pay no matter what, whereas your variable costs are going to change depending on the number of units you produce and sell. I don't think I wrote anything else for this part. They wrote let x equal the number of units, but we're already using Q, so we can ignore that. So we've got here, draw a little line. Our total revenue is going to be the price times quantity. And we are selling them for $500. So our P is going to be 500. And what we're trying to figure out is how many Qs we're going to sell Q. So we will leave that as a variable. We know that our fixed cost from the question is, I believe, $1 million. 1 million. And our variable costs from the question are $300 a unit. So variable costs are 300 times the number of units, which is again Q. So we've got total revenue is 500 Q, fixed costs are $1 million, variable costs are 300 Q. And so our equation for total cost, which we see here, equation for total cost is going to equal total cost equals 1 million plus 300 Q. So now we've got the question all set up, and we can begin to solve it. So if we go back and read, it says how many computers must be made and sold given this information before the firm can make a profit. So what we need to do is calculate the break-even point here. So the break-even point is going to be when profits equals 0. And if you think about it, that's when the total revenue from selling the computers evens out with the total cost of selling these computers. So break-even point is when profits equal 0. We know that profits equal, shrink this, move it up. We know that profits equal total revenue minus the total cost. And here we've got our total revenue of 500 Q. So again, that's $500 times number of computers they sell minus our total cost, and our total cost is 1 million plus 300Q. Of course, 300Q is our variable cost. And we said they break even when profits are 0. So we're going to set profits here equals 0. Next, we're going to distribute that minus sign. So we've still got our 500Q. Distributing the minus on the first term, we get minus 1 million. And distributing into the second term, of course, it turns out plus 300Q into a minus 300Q. From here, we want to group like terms. So what we'll do is move the million over. So we've got 1 million. It's going to equal 500Q minus 300Q. Just a little more. We've got 1 million equals 500Q minus 300Q leaves 200Q. We're then going to divide both sides by 200. And our Q star, or our break-even point, is going to be 5,000. Give me a second to check this. I just want to ensure I didn't miss anything. Tutor, junior tutors get the same answer. Work through that kind of slowly, so maybe I'll just go over the entire thing again really quickly. Our profit equation is going to be profits are equal to total revenue minus total cost. Of course, total revenue is equal to the price of whatever we're selling, in this case laptops, times the quantity sold of that thing. And our total cost is going to be made up of our fixed cost plus our variable cost. And our variable cost will increase with the number of units sold. From the question, we've got our total revenue equals a price of 500 to P times Q, which we don't know at this point. Fixed cost of 1 million, variable cost of 300Q, and therefore total cost of the fixed cost plus the variable cost, or 1 million plus 300Q. The question asks, how many computers must be made and sold given this information before the firm makes a profit? So the break-even point is going to be when profits are equal to 0. This is when total revenue and total costs are the same. So to solve, we set the profit equal to 0. And we take the total revenue, 500Q, subtract the total cost, 1 million plus 300Q. From here, we distribute the minus sign. We get 500Q minus 1 million minus 300Q. We're going to add 1 million to both sides. So we now get 1 million is equal to 500Q minus 300Q. 500Q minus 300Q yields 200Q. And if we divide both sides by 200, we get that our Q star, or our break-even point, is 5,000. I'll give you guys another second to take a picture of that before we move on here. Excellent analysis. That is correct.